Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about the two different types of planets that we find in the solar system. So we can very easily divide our solar system into two types of planets, and we'll look at them here. And then in the future, we will be looking at how this applies to other solar systems. So let's look at what we have. First of all, we have two types of planets. We have the terrestrial or Earth like planets, which includes Mercury, Venus, Earth, and Mars. These all have nice solid surfaces where we could land. The other type of planet is the Jovian planet. So the Jovian planets are Jupiter like. So this is Jupiter, Saturn, Uranus, and Neptune. And none of these have a solid surface. They're all very gaseous and icy. And in fact, we can look at the properties of these two types of planets. And what we see is that they are really complete opposites of each other. The terrestrial planets are small. The Jovian planets are large, both in size and mass. Terrestrial planets are rocky, while the Jovian planets are all gaseous and icy. The terrestrial planets have a solid surface, while the Jovian planets do not. Terrestrial planets have a high density, while the Jovian planets are a low density. The terrestrial planets rotate slow, the Jovian planets fast. Magnetic fields are very weak on the terrestrial planets, but very strong on the Jovian planets. Terrestrial planets have no rings and hardly any moons, while as the Jovian planets, each Jovian planet has a ring system and a good system of moons as well. And then finally, terrestrial planets close to the sun, while the Jovian planets are far from the sun. Now we want to think about this. Why might we have two types of planets? And we will come back and look at this in a little bit more detail later on. But really the key is that they formed at different temperatures. In the solar nebula, when the solar system was forming, we had higher temperatures close to the sun. So when you were close to the sun, the only things that could condense were rocky materials and metallic materials. They are the only things that could form solids that became the building blocks of the terrestrial planets. Icy materials were unable to condense until you got far enough out in the solar system. So when you got far from the sun, now you can condense ices as well, giving us far more material to build from. So in the outer solar system, you not only had the rock and metal that you had in the inner solar system, but you also had the icy material, and that allowed for larger planets to form. Now, when I say ices, I do want to specify what we mean by that. A lot of the ice is water ice, but we also mean things like ammonia, which is nitrogen and hydrogen, and methane, which is carbon and hydrogen combined. So these are all different ices that we will see when we look, especially in the outer portions of the solar system. Now, how do these planets change over time? Well, one way we change as they form is through differentiation. And this is a separation of material by density. And what that means is that the densest objects fall down to the core, and that the density will decrease as you move up toward the surface. So if we think about that in Earth, we have a metallic core, we have a rocky mantle and crust, and we have a gaseous atmosphere. So the very low density is the atmosphere surrounding us, the middle density rocky material within much of the Earth, and then the large core being the metallic, the densest material. Now, it's not just differentiation. That's one way planets change initially, but after they have formed, they can also have different geological activity. So any object with a hot interior, such as Earth, will have this as a possibility. And here we see a lava flow out in Hawaii, where material from the interior of the Earth, from the upper mantle that is molten, will then flow up through through volcanoes and then give us a new material. So new material that is now present. So it is a way of changing the surface of a planet. And we will see that some planets are far more active than others, Earth being very active for a planet. Something like our moon being very inactive, being essentially unchanged over time. for billions of years, and other planets in between that. And we'll also see some interesting things when we look at the moons of the different planets. Now, the other thing that can change the surface appearance of a planet is uh, the impacts. So you can have impacts on the surface that will change the surface patterns. Don't see a lot of impacts on Earth, a relatively small number, maybe about 150 to 200 impact craters that are known. When we look at the moon, we see far more impacts, and places like Mars are kind of a mixture, where some areas have a lot of impacts and others do not. But these change the surface appearance and also give us a way to tell how old the planet is. The more craters we see, the older the surface, the longer since there has been any kind of geological activity or weathering activity that may have worn down those craters. So these are different ways that the planets can change over time. And again, we will look at a lot of this in more detail as we work our way through the chapters of the text. So let's go ahead and finish up with our summary. And what we looked at in this lecture was we have two very distinct types of planets in the solar system, the terrestrial or Earth-like, and the Jovian or Jupiter-like. We believe they're different because they formed in different regions of the solar system with different temperatures. And that's the key, is that we have differing temperatures that existed there. And the surfaces in the solar system have been modified by various processes, such as weathering and volcanic activity and impact craters that change the surfaces over time. So that concludes this lecture on two types of planets. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.